I'm Durga and I would like to present about our problem-based task was given to us for our fiber optic connector. So question 1 is basically calculation. They have given us incident angle of fiber which is 28 degree and the index of reflection of core and cladding which is 1.48 and 1.25 respectively. So part 1 they are asking us to calculate the reflection angle at the air core interface. So the formula for the air core interface is refractive index 1 times angle of incident equals to reflective index 2 times angle of reflection. So now we must find the angle of reflection. But the angle of index 1 they have given, which is for air is 1 and the scene is 28 degree. The angle of incidence 28 degree equals to 1.48 uh, scene, and we don't know the angle of reflection. So after we calculate, we'll get 18.5. With this formula, when we use, we get the answer for the refraction angle, which is 18. So the refraction angle at air core interface is 18.5 degree. So the second question, they ask us to calculate the critical angle at the core cladding interface. So the formula for this is C critical angle equals to refractive index 1 divide reflective index 2. So by moving the scene to this side and then the index 1 and index 2 they have given us, which is 1.5 and 1.5, representation of core and cladding. After we calculate, we'll get the critical angle at the core cladding interface is 57.6 degree. And the third question, they are asking us for the numerical aperture and the acceptance angle for the multimode fiber optic cable. So this is for the numeric aperture, which is refractive index 1 square minus refractive index 2 square uh, power of half. So when we calculate with the refractive index 1 and 2 for the numerical aperture, we will get 0.79 for the square. And for question 4, they are asking us acceptance angle. So to calculate acceptance angles, we need numerical aperture. That's why we calculate numerical aperture first. So for acceptance angles, C bracket 0.79, which is the numerical aperture. So we'll get the acceptance angles, which is 52.19. To calculate the acceptance angles, we should know the numerical aperture. And to calculate the critical angle, we need refraction angle at air core interface. This is how all this 4 part is connected. So that's all from me. Thank you.
I'm going to explain about question 2. The wavelength division multiplexer WDM is one of the techniques in optical frequency division multiplexing. Explain the concept of WDM and build WDM block diagram. The answers for question 2 is WDM is one of the optical multiplexing technique that increase bandwidth by multiplexing a variety of optical carrier signals onto a single optical fiber by using different wavelengths. Each signal at WDM wavelengths is independent of any protocol and any speed. The WDM technology always bidirectional communication seamlessly over a single optical fiber. The foundation of WDM simplifies the network to a single virtual optical fiber network instead of using multiple forms of single signals with different fiber and services. In this way, WDM increases the bandwidth and lowers the networking cost by reducing the needed fibers. There are two different wavelength patterns of WDM system: coarse CWDM and dense DWDM. That's all from me. Thank you.
My name is Muhammad Farid bin Ma'arif and my matrix number is 01DDT119F1148. Today I will present about my subject fiber optic communication on practical based task on question 3. Okay. Question is about is one passive optical network system utilize a passive splitter that takes one input and split it to broadcast signal downstream to many users. illustrate basic PON architectures, terminate diagram with different type of fiber to the loop FTTL. Okay, this is a picture of passive optical network. Internet, PSTN, KATV, OLT, Central Office, Optical Fiber, Passive Optical Splitter, ODN, ONO, User User End. Go to the user. Internet, PSTN, KTV, go to OLT, go from optical fiber, passive optical splitter, and go through ONO and get to the user. Okay. A passive optical network PON refers to the telecommunication technology that implements a point to multi-point architecture. The PON architecture consists of three main units, OLT, ONO, and ODN. OLT located in CO in the interface between PON and the optical backbone network. OLT distribute PSTN internet and KATV service to as many as 16 to 100 end users per fiber line. Passive optical splitter divides an optical signal into multiple equal low power signals and distributes them to end user during downstream, and in case upstream transmission, this acts power combiners. ONO provides service interface to end users. ODN connects OLT and end users using optical fibers. ODN. O optical, T distribution and network. And ODN realized that optical transmission from the OLT towards the user and vice versa, it utilize passive optical components. OLT, optical line termination. An OLT is service provide endpoint of a PON and displays in a CO or head-end. On or no optical network termination. An on is a device that terminates the PON and present native service interface to the user. And on is a typically located on the customer premises. Ni to optical line termination, optical fiber, passive optical splitter, go to optical network termination, optical network go to optical network termination and go to the user end, go to the people. Okay, thank you. I stop my presentation here.